So, good day everyone. Today we'll be talking about sample problems for tolerance. Start ta sa number 2. Diametral clearance for H8 and D8 feet. An assembly uses a diameter 50, H8, and D8 feet. The hole limit for diameter 50 H8 are 50 mm to 50.039 mm. And the shaft limits for diameter 50 D8 are 49.881 mm to 49.92 mm. Calculate the maximum and minimum diametral clearance for this assembly. For the diagram, so this is the hole. Yan siya. Yan siya. Kanina ay kini. Then the shaft. So the minimum hole for the minimum shaft na atay 49.881 mm and a maximum of 49.920. For the hole, minimum 50 and for the maximum na atay 50.0039. Then for the solution, to solve for the maximum clearance, minus na to ang maximum hole sa minimum shaft, which is 50.039 minus 49.881 at a maximum clearance, which is equivalent to 0.158 millimeter. Then to solve for the minimum, we will use the formula of minimum clearance is equivalent to minimum hole minus maximum shaft. Substitute 50 minus 49.920 millimeter is equal to 0.08 millimeter sa ato ang minimum clearance. So ang answer is for the maximum is 0.158 and for the minimum clearance is 0.08 millimeters. Next, number 3, mean dimensions and radial clearance. For the diameter 50 H8 D8 feet described above, assume the manufacturing process tolerance is centered. Determine the mean hole diameter, the mean shaft diameter, and the resulting radial clearance. So for the diagram, diagram diri same lang gyapon sa above, same lang gyapon ang given. So diretso na ta sa ato ang solution. So to solve for the mean hole diameter, natay formula which is minimum hole minus maximum hole divided by 2. Since naman ta both, add na to sila, which is 50 plus 50.039 divided by 2, which will be 50.0195 millimeter of mean diameter hole. For the mean shaft diameter, same lang yapon. So minimum shaft plus maximum shaft divided by 2. So 49.881 plus 49.920 divided by 2, we will have an equivalent of 49.9005 millimeter of diameter shaft. To solve for the radial clearance, we will use the mean diameter hole, subtract it by the mean diameter shaft and divided by 2. So 50.0195 minus 49.9005 divided by 2, we will get a result of radial clearance which is equivalent to 0.0595 millimeter. The next, clearance for H7 and E7 feet. A journal bearing with a nominal diameter of 100 millimeters uses an H7 E7 feet. The hole limits for diameter 100 H7 are 100 millimeter to 100.035 millimeter, and the shaft limits for diameter 100 E7 are or 99.893 millimeter to 99.928 millimeter. Calculate the diametral clearance based on the diameters of the hole and shaft. So for the diagram, diagram na rin is klaro. Same lang yapon previously na itong hole then shaft. So para sa ito ang hole is naman given a minimum hole which is 100, then maximum hole which is 100.0.35. For the shaft, natin minimum shaft na 99.893, and for the maximum is 99.928 millimeter. For the solution, same lang yapon previously sa number 3 na minimum hole plus maximum hole over 2. Substitute lang na din tayo answer na 100.0175 millimeter. For the shaft, minimum shaft plus maximum shaft 99.893 plus 99.928 divided by 2 is equivalent to 99,105. So for the diametral, we will just minus the mean diameter hole sa mean diameter shaft. So 100.0175 minus 99.9105 is equivalent for 0.107 millimeter. So ano to final answer for the diameter clearance. The next, minimum film thickness variable. In a bearing application where the radius to clearance ratio R over C is assumed to be 1000 and the radial clearance is 0.05 millimeter, a calculation yields a minimum film thickness of 0.02 millimeter. Calculate the minimum film thickness variable for these conditions. So for this diagram natin bearing. So this is the radius inside the hole. So dito to ang kanasyon. Diri ato ang minimum film thickness. Then clearance na to natin ibabaw. Kanang gamay jud kayo. So clearance mo na tong radius. So for the given atay ratio to clearance is equivalent to 1000 millimeter. Then radial clearance which is equivalent to 0.05 millimeters. Then minimum film thickness is equivalent to 0.02. So the solution diretso na ito na siya. HO minus C. Since given naman, gihatag naman sa itong formula, we just substitute 0.02 millimeter over 0.05 millimeter. Cancel the units. So ato ang minimum film thickness variable is equivalent to 0.4. Next, standard US standard versus oversized hole dimensions. A designer is specifying holes for a connection using 3/4 inch diameter bolts. Determine the diameter of a standard size bolt hole and the diameter required if the application specifies an oversized hole for ease of assembly. For the diagram, this is the bolt and the hole. So ito natay diameter of the bolt which is 3/4 inch. Not to given. For the solution, use the standard diameter which is equivalent of diameter plus 1/16. So it's mo ano siya standard sized bolt. Then substitute 3/4 plus 1/16 inch is equal to 13 over 16 inch. Convert to decimal is 0.8125 inch. Then next, for the oversized uh, diameter, D is outside diameter is equal to D plus 3/16. Substitute 3/4 plus 3/16 is equal to 15/16 inch. Convert it into decimal form, 0.9375 inch. That is all. Thank you.